An intermodal container is a standardized reusable steel box. They are used to store and move materials and products in the global containerized intermodal freight transport system efficiently and securely. Intermodal indicates that the container can be moved from one mode of transport to another without unloading and reloading the contents of the container. Lengths of containers, which each have a unique ISO 6346 reporting mark, vary from 8 to 56 feet and heights from 8 feet to 9 feet 6 inches. There are about 17 million intermodal containers in the world of varying types to suit different cargoes. For air freight, the alternative and lighter IATA-defined unit load device is used. Non-container methods of transport include bulk cargo, break bulk cargo and tank cars, tank trucks or oil tankers used for liquids or gases. History. The standardized steel shipping container has its origins in the 1950s when commercial shipping operators and the United States military started developing such units. Shipping owner Malcolm McLean worked with engineer Keith Tintlinger to develop the modern intermodal container. The logistics method employing these was named Container Express and was abbreviated conex. That abbreviation evolved into a word within the American English lexicon. ISO standards for containers were published between 1968 and 1970 by the International Maritime Organization. These standards allow for more consistent loading, transporting, and unloading of goods in ports throughout the world, thus saving time and resources. The International Convention for Safe Containers is a 1972 regulation by the Intergovernmental Maritime Consultative Organization on the safe handling and transport of containers. It decrees that every container traveling internationally is supplied with a CSC plate. Description: a typical container has doors fitted at one end, and is made of corrugated weathering steel. Containers were originally 8 foot wide by 8 foot high, and either a nominal 20 foot or 40 foot long. They could be stacked up to 7 units high. At each of the 8 corners are castings with openings for twist-lock fasteners. The standard height is now 80 ft 6 in. Taller units have been introduced, including high cube, or high cube units at 9 feet 6 inches and 10 feet 6 inches high. The United States and Canada often use longer units at 48 ft and 53 ft. The pallet-wide containers are about 2 inches wider than standard containers to accommodate Euro pallets, common in Europe. These containers feature an internal width of 2,440 mm for easy loading of two 1,200 mm long pallets side by side. Many sea shipping providers in Europe allow these as overhangs on standard containers are sufficient and they fit in the usual interlock spaces. Australian race containers are also slightly wider to accommodate Australia standard pallets. Especially the 45 ft pallet-wide high-cube short sea container has gained wider acceptance, as these containers can replace the 13.6 am swap bodies that are common for truck transport in Europe. The EU has started a standardization for pallet-wide containerization in the European Intermodal Loading Unit Initiative. Container capacity is often expressed in 20-foot equivalent units. An equivalent unit is a measure of containerized cargo capacity equal to one standard 20 FTA, IATA container. As this is an approximate measure, the height of the box is not considered. For example, the 9 ft 6 in high cube and the 4 foot 3 inch half height 20-foot containers are also called 1 TEU. Similarly, the 45 ft containers are also commonly designated as 2 TEU, although they are 45 feet and not 40 feet long. 2 TEU are equivalent to one 40-foot equivalent unit. Swap body units use many of the same mounting fixings as intermodal containers, but have folding legs under their frame so that they can be moved between trucks without using a crane. They are generally lighter in weight. The containers flex during transport. Types. Variations on the standard container exist for use with different cargoes, including refrigerated container units for perishable goods, tanks in a frame for bulk liquids, open-top units for top loading and collapsible versions. Containerized coal carriers and bin liners are used in Europe. Container types include collapsible ISO, gas bottle, generator, general-purpose dry van for boxes, cartons, cases, sacks, bales, pallets, drums in standard, high or half-height, high-cube pallet-wide containers for Euro pallet compatibility, insulated shipping container, refrigerated containers for perishable goods, open-top bulkers for bulk minerals, heavy machinery, open side for loading oversized pallet, platform or bolster for barrels and drums, crates, cable drums, out-of-gauge cargo, machinery, and processed timber, rolling floor for difficult-to-handle cargo, swap body, tank container for bulk liquids and dangerous goods, ventilated containers for organic products requiring ventilation, garmentaners for shipping garments. On hangers, flush-folding flat rack containers for heavy and bulky semi-finished goods, out-of-gauge cargo. Empty flat racks can be stacked or shipped sideways in an ISO container. Specifications, weights and dimensions of some common types of containers. Values vary slightly from manufacturer to manufacturer. Security. Intermodal containers can be the target of break-ins and burglary when left unattended since they often contain valuables. In these cases, a security system consisting of a motion detector and panel can trigger a siren, strobe, or light to deter intruders. Many panels have wireless communication so that security guards can be alerted if an alarm is triggered. Motion detectors can be used as a security method. However, many break-ins occur by criminals cutting through a wall of the container, so the obstructed sensor becomes useless. Tomographic motion detectors work well in intermodal containers because they do not require a line of sight to detect motion. The entire container is covered by a volumetric sensing mesh that is not blocked by equipment or inventory. Tomographic motion detection is not prone to misdetection due to dirt buildup as is the case for beams and infrared sensors. Stacking containers. At stacking load-bearing locations, 40-foot containers are the standard unit length, and 45 AFT, 48 AFT, and 53 AFT all stack at the 40 AFT coupling width. Other units can be stacked on top of 20 AFT units only if there are two in a row, and 20 AFT units cannot be stacked on top of 40 AFT units, or any other larger container. The coupling holes are all female and it takes a double male twist lock to securely mate container stacks together. Larger containers, 53-foot container. Introduced in 1989, the 53 AFT shipping container is considered a high-cube container in that it is 9 AFT 6er and tall on the exterior. It is 1 AFT taller than standard height containers. It is 8 AFT 6er in wide, which makes it 6er in wider than standard containers. The bigger boxes have 60% more capacity than standard 40-foot containers, enabling shippers to consolidate more cargo into fewer containers. The original domestic 53-foot box OTR containers were introduced in 1989, but in November 2007 the first 53-foot ocean containers were introduced. All new, reinforced 53-foot boxes are built specifically for international trade and designed to withstand ocean voyages. According to APL, 53-foot containers could become the transport method of choice for customers moving cargo. In March 2013 APL stated that it no longer offers vessel space for 53-foot ocean containers in its Trans-Pacific services. It has struggled to find sufficient amount of U.S. export cargo for them, while revenue on the eastbound leg has not been sufficient to cover the costs of repositioning empties back to Asia. Reporting mark. Each container is allocated a standardized ISO 6346 reporting mark, 4 characters long ending in either U, J or Z, followed by 6 numbers and a check digit. The ownership code for intermodal containers is issued by the Bureau International des Containers et du Transport Intermodal, hence the name BIC code for the intermodal container reporting mark. So far there exist only 4-letter BIC codes ending in U. The placement and registration of BIC codes is standardized by the Commission's TC 104 and TC 122 in the JTC 1 of the ISO, which are dominated by shipping companies. Shipping containers are labeled with a series of identification codes that includes the manufacturer code, the ownership code, usage classification code, UN placard for hazardous goods, and reference codes for additional transport control and security. Following the extended usage of pallet-wide containers in Europe, the EU had started the Intermodal Loading Unit initiative. This showed advantages for intermodal transport of containers and swap bodies. This led to the introduction of ILU codes defined by the standard EN 13044, which has the same format as the earlier BIC codes. The International Container Office BIC agreed to only issue ownership codes ending with U, J or Z. The new Allocation Office of the UIRR agreed to only issue ownership reporting marks for swap bodies ending with A, B, C, D or K. Euro companies having a BIC code ending with U can allocate an ILU code ending with K having the same preceding digits. Since July 2011, the new ILU codes can be registered. Beginning with July 2014, all intermodal ISO containers and intermodal swap bodies must have an ownership code, and by July 2019 all of them must bear a standard conforming placard. Handling and transport. Containers can be transported by container ship, semi-trailer truck, side-lifter and freight trains as part of a single journey without unpacking, and they are transferred between modes by container cranes at container terminals. Units can be secured during handling and in transit using twist lock points located at each corner of the container. Every container has a unique BIC code painted on the outside for identification and tracking, and is capable of carrying up to €25 tons. Costs for transport are calculated in 20-foot equivalent units. Rail. When carried by rail, containers may be carried on flat cars or well cars. The latter are specially designed for container transport, and can accommodate double-stacked containers. However, the loading gauge of a rail system may restrict the modes and types of container shipment. The smaller loading gauges often found in European railroads will only accommodate single-stacked containers. In some countries, such as the United Kingdom, there are sections of the rail network through which high-cube containers cannot pass, or can pass through only on well cars. On the other hand, Indian Railways runs double-stacked containers on flat cars under 25 kV overhead electrical wires. In order to do this, the wire must be at least 7.45 meters above the track, but IR is able to do so because of its large loading gauge and the extra stability provided by its 1,676 ohm track. China Railways also runs double-stacked containers under overhead wires, but must use well cars to do so, since the wires are only 6.6 meters above the track and 1,435 ohm does not provide adequate stability to run double-stacked containers on flat cars. Ship. Each year an estimated 10,000 shipping containers fall into the sea. Of these, 10% are expected to contain chemicals toxic to marine life. Securing loads in intermodal containers. There are many established methods and materials available to stabilize and secure cargo in intermodal containers. Conventional restraint methods and materials such as steel strapping and wood locking and bracing have been around for decades and are still widely used. Polyester strapping and lashing, synthetic webbings are also common today. Tonnage bags, also known as airbags, are used to help keep unit loads in place. Flexi bags can also be directly loaded, stacked in food-grade containers. Indeed, their standard shape fills the entire ground surface of a 20 ISO container. Non-shipping uses. Containers have been used for other purposes at the end of their voyaging lives. Permanent or semi-permanent placement for storage is common. A container has 8,000 lb of steel, which takes 8,000 kWh of energy to melt down. Repurposing used shipping containers is increasingly a practical solution to both social and ecological problems. Shipping container architecture employs used shipping containers as the main framing of the modular home designs, where the steel may be an integrated part of the design, or be camouflaged into a traditional-looking home. They have also been used to make temporary shops, cafes, and computer data centers, for example, the Sun Modular Data Center. The Russian 3M-54 Club surface-to-surface missile can be launched from a platform based on shipping containers, and transported as one. Intermodal containers are not constructed for conversion to underground bunkers, as the walls cannot sustain much lateral pressure, and will collapse. Also, the wooden floor of many used containers could contain some fumigation residues, rendering them unsuitable as confined spaces, such as for prison cells or bunkers. Cleaning or replacing the timber floor can make these used containers habitable, with proper attention to such essential issues as ventilation and insulation. See also. References. Further reading, George, Rose. 90% of everything, Inside Shipping, the Invisible Industry That Puts Clothes on Your Back, Gas in Your Car, and Food on Your Plate, describes typical sea voyage. Excerpt and text search, International Organization for Standardization, Freight Containers, Volume 34 of ISO Standards Handbook, International Organization for Standardization, 4th edition, 2006. ISBN 92-67-10426-8, Levinson, Mark. The Box, How the Shipping Container Made the World Smaller and the World Economy Bigger, Princeton, New Jersey. A Princeton University Press, 2006. ISBN 0-691-12324-1. Excerpt and text search, Donovan, Arthur and Bonney, Joseph. The Box That Changed the World, East Windsor, New Jersey, Commonwealth Business Media, 2006. ISBN 978-1-891131-95-0. External links, International Convention for Safe Containers.